A wheel has a radius of 0.4 meters, so we can put that first value, and is mounted on frictionless bearings. A block is suspended from a rope that is wound on the wheel and attached to it. The wheel is released from rest, and then the block descends 1.5 meters in 2 seconds without any slipping of the rope. The tension in the rope during the descent of the block is 20 newtons. What's the moment of inertia in the wheel? So we're looking for the inertia here. And then the first thing we can start doing is moving around the equation of distance. So the distance is going to be the initial velocity times the time plus half of the acceleration times the time squared. And then in this case, we can already assume that the initial velocity is 0 meters per second since the wheel was at rest at the beginning of the problem. And we do have the rest of these values, so we would put in the 1.5 meters for the distance. This part of the problem is automatically going to become 0 since the initial velocity is 0. So we're just left with half of the acceleration times the time that we know is 2 squared. And then from there we can do 1.5 divided by 2 equals 2a divided by 2. And that leaves us with an acceleration of 0.75 meters per second. So now we can work with this value to find the true inertia. So the first thing that we're going to do for the inertia is try to do a net torque. So the torque here is equal to the tension times the radius. And when we convert the net torque, this is equal to the inertia times the acceleration, and that's equal to the radius times tension. So this is just in different terms the same equation. And now let me erase so I can get some more space. To calculate the inertia, we're also going to have to remember, though we have the acceleration, we want the acceleration in different terms. We're going to do the acceleration over the radius. So we're going to do the inertia times the acceleration over the radius is going to be equal to the radius times the tension. And this is going to give us, once we simplify this, inertia times the acceleration times r squared times the tension. And then to isolate the inertia, we would have the radius squared times the tension over the acceleration. So now we can start finally plugging in these values. We know that the radius is 0.4 meters squared, and we know that the tension is 20 newtons. And then we know that the acceleration that we found is 0.75 meters per second squared. And once you plug in all these values, it leaves you with around 4.26 kilograms times meter squared. And then the closest value that we have on our answers, the closest to 4.26 would be option E, 4.3 kilograms times meters squared.